So a very warm welcome to our resource person, dynamic resource person, Professor Sudeep Mishra. Uh, Today we have with us Dr. Rashid Ali, Professor, Department of Computer Engineering, Aligarh Muslim University, Aligarh. And we have a wonderful lecture on IoT today. So I will request Professor Rashid Ali to please introduce our today's first resource person, Professor Sudeep Mishra from IIT Kharagpur.
Thank you, Dr. Abdul Samad. Professor Sudeep Mishra is a professor and Abdul Kalam Technology Innovation National Fellow in the Department of Computer Science and Engineering at the Indian Institute of Technology, Kharagpur. He received his PhD degree in computer science from Carleton University, Canada. His current research is and Internet things. Professor Mishra has published over 350 scholarly research papers.
राशिद साहब थोड़ा सा माइक ठीक कीजिए प्लीज, एक्सक्यूज मी, थोड़ा सा आवाज आपकी कम है.
Okay, fine. Now it's okay. So
yes, please go ahead.
Okay, fine. So Professor Mishra has won 9 research paper awards in different conferences. He was awarded the IEEE ComSoc Asia Pacific Outstanding Researcher Award at IEEE Globecom 2012, California. He is also the recipient of several academic awards and fellowships, such as the Faculty Excellence Awards, IIT Kharagpur, Young Scientist Award, National Academy of Sciences, India, Young System Scientist Award, System Society of India, Young Engineers Award, Institute of Engineers, India, Canadian Governor General Academy Gold Medal at Carleton University, the University Outstanding Graduate Student Award in the doctoral level at Carleton University, and the National Academy of Sciences, India, Swan Jayanti Purashkar, Golden Jubilee Award, Samsung Innovation Award 2014 at IIT Kharagpur, IET Biman Bihari Sen Memorial Award 2014, and the Careers 360 Outstanding Faculty Award in Computer Science for the year 2018 from the Honorable Minister of Human Resource Development of India. He is the recipient of IEEE Systems Journal Best Paper Award 3 times, 2018, 19, and 2020. He was awarded the Canadian government's prestigious NCRC Postdoctoral Fellowship and the Alexander von Humboldt Research Fellowship in Germany. His team received the Gaiety Award 2018 in the hands of the President of India for socially relevant innovations. Dr. Mishra has been serving as the associate editor of different journals, such as the IEEE Transaction on Mobile Computing, IEEE Transaction on Vehicle Technology, IEEE Transaction on Sustainable Computing, IEEE Network, and IEEE Systems Journal. He is the fellow of the National Academy of Sciences, India, Indian National Academy of Engineering, the Institution of Engineering and Technology, UK, British Computer Society, UK, Royal Society of Public Health, UK, and Institution of Electronic and Telecom Engineers, India. Professor Mishra is the distinguished lecturer of the IEEE Communication Society. He has been serving the executive committee of IEEE Kharagpur section since 2008 in different capacities. Presently, he is the vice chair of the IEEE Kharagpur section. He is the director and co-founder of the IoT startup Sensor Drops Networks Private Limited. So in short, Professor Mishra has authored more than 300 publications, has won several academic research awards at national and international levels, has won research paper awards, invited as editors and editorial members of many international journals, invited for keynote lectures in over a dozen international conferences held in North America, Europe, Asia, and Africa. He has been invited as program chair, publication chair, publicity chair, and session chair in many conferences. I welcome you, sir. We are pleased to have you as a speaker in our FDP. Thank you, sir, for accepting our invitation. So you can now start.
So thank you very much, Professor Ali, for this introduction. And I'm very pleased to be able to participate in this particular FDP. So thanks to you, thanks to Professor Samad, and thanks to the administration of Aligarh Muslim University for inviting me for this FDP. Yeah, unfortunately, we are not able to meet physically this time, but I still remember, if I remember correctly, it was in 2018 when I visited your very beautiful campus in AMU. And so, yeah, I think now, everything will have to happen virtually until things normalize. Thank you all, and thanks to all the participants too for taking your time to be present for this particular session. Without any further delay, I'm going to start my talk. First, I'm going to share my slide. So please give me a moment until I do so. I have shared my slide. Are you able
Yes,
to
sir.
see
The
it?
slides are visible.
Okay,
Yes, sir.
thank you. Thank you. So, as you have heard, that I am from IIT Kharagpur, and I belong to the Computer Science and Engineering Department. I direct the Smart Wellness Applications and Networking Lab. I lead it, and so this particular lab, as many of you know, throughout the country, it has done some very fundamental works on IoT, particularly focused on IoT networks. There are a lot of lot of research work, innovative research works that have happened from this lab. A lot of PhD theses have come out, and a lot of innovative activities have been taking place. So what I'm going to do today is I'm going to talk about IoT, fundamentals of IoT, and particularly focused on the issues of convergence, particularly cross-domain convergence and innovation. So initially, I'm going to talk about the generic issues and the research centered on these issues that are being carried out throughout the world. And towards the latter part of my talk, I'm going to focus more on the specific research, some of the research works that have been done in the Swan lab. So those of you who did not visit IIT Kharagpur, it is in West Bengal. So we are located, Kharagpur is located about 150 kilometers from Kolkata, and basically, it is a place where a lot of famous personalities. It is the first IIT that was set up after independence, and so there are a lot of so since then a lot of other IITs have come up, and so many famous personalities, for example our Google CEO and many others actually are they graduated from IIT Kharagpur. So it's one of the biggest campus. It is not only the oldest IIT, but also it has the biggest campus. It has, in terms of the number of departments, in terms of the number of students, in terms of the number of faculty, in every respect, in terms of the size particularly, in every respect, basically IIT Kharagpur among all the IITs is the biggest. This is a brief about IIT Kharagpur. These are some of the pictures of some of the important important buildings in the campus. So I was telling you that this Swan group, Smart Wellness Applications and Networking Research Group, is the one that I lead, and so it has has produced a lot of PhD students, PhD graduates, PhD thesis have been produced from this particular group, and all under my mentorship. And so earlier, previously, we used to focus more on the simulation and analytical works, but lately, since about 6 to 7 years, last 6 to 7 years, we are also doing a lot of real experimental works. So many of our works have resulted in prototypes, lab-based prototypes, which eventually evolved into actual products, which are being commercialized through a startup company that is incubated in the Science and Technology Entrepreneurship Park in IIT Kharagpur. The name of this company is Sensor Drops Networks. So those of you who are curious to know more about this particular company, from where we are basically we are commercializing the solutions, some of the research solutions that have come out from this lab. So please visit the website www.sensordropsnetworks.com. If you search with this name also, you will be able to get the link to the URL, and please feel free to visit this website. And in case you are interested to know more about our products, or if you know of any other company or anybody else who might be interested in our products, so please feel free to contact us. You can contact me, or you can contact the contact email address that is given in the Sensor Drops website for further information. In terms of research, as I was telling you, we are focused on the networking aspects of IoT. And when we talk about IoT, there are a lot of different aspects, individual enabling technologies, a lot of different enabling technologies are there. So, after my PhD, more than 15 years back, I started my research on ad hoc and sensor networks. Those days, wireless ad hoc networks was popular. And after ad hoc networks, initially it was like mobile ad hoc networks being popular, then came the vehicular ad hoc networks. So after the popularity of ad hoc networks, then emerged wireless sensor networks. So I devoted a lot of time on research on wireless sensor networks. In wireless sensor networks, apart from the innovations in the different networking aspects, we also did a lot of work on the applications, particularly applications on healthcare, applications in mining, and so on. So applications in healthcare focused on wireless body area networks, right? So physiological, basically for wireless body area networks for physiological monitoring of individuals. So we did a lot of work on that. Then we also worked on something called multimedia sensor networks. So basically it's the same sensor networks, but in addition to the scalar sensors like temperature or pressure, etc., you also have vector-based sensors like cameras. So cameras, basically, you get camera feeds, which could be still images, which could be video camera frames, right? Streams of frames coming through. So like that, so we have been working on the multimedia sensor networks. Even in multimedia sensor networks, not only terrestrial multimedia sensor networks, that means these multimedia sensor networks which are deployed on the surface of Earth. Not only those, we also did a lot of work on something called underwater multimedia sensor networks. So basically, you can conceptually think of the same multimedia sensor networks as you know, or as as people have worked on for the terrestrial environment, but also basically thinking that how you can deploy similar kind of setup under the surface of water, right? Under the water surface. So basically, inside oceans, like in the ocean columns or other water bodies, how you can come up with multimedia sensor networks for monitoring the ocean, monitoring under the water in oceans or different other water bodies. So what you can do. So basically, we did that also. It's a very challenging domain, multimedia sensor networks for underwater, it's a very challenging research area. The reason being that these are actually very low data rate networks. These sensor networks are very low data rate networks, and particularly when you are talking about underwater sensor networks, you have an acoustic channel, and unlike the RF, basically here you have to use sound waves for communication, and that actually reduces the overall efficiency of the communication channel drastically, and consequently what happens is that you cannot really send a lot of traffic too fast. You cannot do that, right? So there is an inherent limitation of the channel. So we worked on that. Even if you have the inherent limitation of the channel, how you can come up with some solutions to still work in the presence of those limitations, right? So that is basically multimedia, underwater multimedia sensor networks. We also worked on opportunistic mobile networks. Today I will talk about opportunistic mobile networks a little bit, so we are going to cover that also. So I will skip it for now. I did a lot of work on smart grid too. So all of these basically, so these, they may look like different areas, but actually what we focused on are the networking aspects as is relevant for IoT. So if you are thinking about, if you are conceptualizing, if you are building an IoT network, so how these things, these different areas they fit in is basically our focus in terms of the research, right? So smart grid we worked a lot on network security, again from an IoT point of view. Then we also did some work on nano sensor networks. So when we talk about nano sensor networks, here actually there are two types of nano sensor networks we can think of. The nano sensor networks which are terrestrial, right? And which are atmospheric, terrestrial, and so on. And nano sensor networks which are inside the human body, right? So those are called basically the bio nano sensor networks. So we did work on both. We did work on both, but so lately actually our focus has been on the bio nano sensor networks. So most of our works on this nano sensor domain is mostly analytical and simulation based, because we still do not have the technology in place to be able to do real experimental work. So this biosensor networks, what we so the scope of bio-nanosensor networks is that inside the human body, if you can place some sensors which are like nano-sized sensors, how those sensors can basically communicate with one another for continuously monitoring the different conditions of the person who has these sensor nodes deployed in there, right? So this is basically, so many times it is used for, this sort of technology is being used for diagnostics of patients who are like critically ill, or diagnostics of patients who have some kind of long-term some kind of long-term ailment, like cancer or heart disease, or some sort of orthopedic problems. So for those actually this kind of nanosensor technology is very useful for long-term continuous monitoring of such individuals. It is also not only used for diagnostics but also for therapeutics. So therapeutics means like, so basically for therapy, right? So what you can do is the individual can swallow some pills which eventually is going to disintegrate inside the body, and maybe get scattered through the bloodstream all around the body. And then these sensors basically, they also have some mechanism, some actuation mechanism, etc., which can maybe so which can give some drugs at some targeted location, right? So it is also called targeted drug delivery, right? So so targeted drug delivery, and so basically so therapeutics, right? So therapeutics, so diagnostics, therapeutics, both with the help of this. But as I said, like unlike the other focus areas on IoT, so here actually we have been limiting ourselves to only this simulation and analytical based works. I'll just give you an example. In the last 2 to 3 years, some of my students, what they did is they worked on some solutions. So initially, they worked on, let us say, dengue virus, right? So they worked on dengue virus. So how this virus spreads inside the body, they worked on that, and the communication between the different, the different viral particles and the different other mechanisms, the immune system mechanisms inside the body. So those kind of modeling we did in terms of the communication, right? So our focus is only on the communication. So this biomolecular communication between the different biomolecules, how the communication takes place. We worked on that. And lately, like since the last year, since the pandemic started, we also diverted ourselves a bit, and we have been looking into how a similar kind of solution can be tailored for use with COVID-19 patients, right? So how you can this COVID-19 virus, so how it spreads inside a human body, starting from the point it gets inside the body, how it is going to spread. So that kind of modeling. So how the different viral particles, they are going to communicate with each other, not only with each other, between the viral particle and also the immune system of the body, how this communication is going to take place. So rest of the things like, fog computing, edge computing, again, so with respect to whatever is relevant for IoT. So we have been doing a lot of work, a lot of papers are there on this. We did a lot of work on UAVs and UAV networks, so particularly quadcopters. We did some works on cyber physical systems, and so on. So like this, actually, there are a lot of different areas which are relevant for IoT and that we have been working on. These are some of the different books that are available. So a couple of books I would like to mention. So Principles of Wireless Sensor Networks, published by Wiley UK. This book has been quite popular in the sensor networks research community. And not only sensor networks research community, but also it is being used as textbooks in different sensor networks courses globally. And also another 2 books, actually, I didn't fix it earlier. Actually, this I should have added. So there are 2 other books. One on IoT itself, Introduction to IoT. This book is published by Cambridge University Press, CUP. There is another companion book, which is basically Introduction to Industrial Internet of Things and Industry 4.0. This particular book is published by CRC Press, Taylor and Francis Group. And so these 2 books are basically available in the market very recently. So starting from January, these books are available through different online agencies like Amazon, etc. So if you search in Amazon, amazon.in with my name, you will be able to get the links to these books for purchase if you want to purchase. So these are the books. Then so with that brief introduction and my overall research, so let me now switch my gear, talk about introduction to Internet of Things. So I thought about, so when I was approached, so I thought about, so what sort of thing I'm going to present over here. So given the scope of the this particular FDP, I felt like, so some of the participants may be interested to know more about the basics than of any advanced research. That is the reason, actually, initially I'm going to talk about some of the basics of Internet of Things. And then also I'm going to devote some time on some of the advanced research that we have done in our lab, right? I'm going to do both. So Internet of Things, so I hope that everyone must have at least heard about this term, Internet of Things. So what is this Internet of Things, right? So let us try to understand that. Just 1 minute, just collapse this thing. Okay. So we all have heard about the internet. We have been using the internet. So internet has become very popular, right? So everybody uses the internet nowadays. Even if you go to some remote rural village, it is quite likely that the persons residing there are using the internet at least through their mobile phone, right? So internet has become very pervasive. Internet is being used quite commonly across the globe throughout, irrespective of irrespective of which part of the world somebody comes from, throughout actually internet has become very popular. Now this was not the case, like, if we think about like 20 years back, right? So internet was there, people used to use them, but internet was not as popular as it is today, right? So earlier, actually, for browsing the internet, I do not know how many of you, particularly the younger attendees over here, you may not be aware much, but earlier days, couple of decades back, like 20 years, 25 years back. So what we used to do is to go to internet cafes. It used to be called like internet cafes, right? So people used to run different businesses, small shops, having couple of computers connected to the internet, browse the web, right? Browse the web or send emails and things of that sort. So, but you see that nowadays you do not have internet cafes, right? Everybody has the internet available on their mobile phone. Everybody, so earlier, previously, there used to be the access to the internet through the telephone web, right? So telephone connection was there, available at homes. So through the wired telephone connection, internet was made available, right? So there used to be something called dial-in modem. So dial-in modems were there, where you had to have a modem that you have to purchase, and then by installing some software, you can dial into some kind of a number in order to connect to the internet. So you see that internet itself has evolved quite a bit, right? Internet itself has evolved quite a bit, and in terms of usability also, so internet has become like really pervasive throughout the world. So, but that internet, the popularity of the internet that it has got, it was restricted to only the computers, connecting the different computers and other computing devices like laptops or PDAs and so on. So internet was limited to connecting the different computers and computing devices. So what people thought about, so several years back, there was, so people thought about that, can we, in addition to different computers, can we also connect the physical objects that we all see around us, right? So there are different physical objects. For example, right now you might be sitting on a chair, so your laptop or the computer through which you are, the desktop that you are connecting with, it is on some desk or some table and so on. So this chair, this table, the lighting system of your room, the air conditioning system of your room, and so on and so forth. So basically, all of these are different candidate things in the scope of Internet of Things. So whole idea is that all these different physical objects that you can see around you, that you can think, the ones that you have been using, so anything and everything that you can think of, right from the toothbrush that you have used in the morning to the rice cooker that you will be using for cooking your rice. Uh, uh, so basically, anything and everything that you can think of are candidate things in the Internet of Things, right? So the whole idea is to internetwork, to connect these different objects, physical objects. Now the question is that, why do you want to connect all these different physical objects? What is the need, right? So basically, the one sentence answer to this question is that you want to deliver some value-added services to the community, to the different stakeholders. You want to deliver some value-added services. So there are different attractive use cases that we can think of, which can deliver some attractive services to the community, to the users, by networking, by interconnecting these different physical objects. So in the IoT world, you will be in an ecosystem where all these physical objects like the chairs, the tables, the lighting system, the air conditioning system, the toothbrush, the rice cooker, and anything and everything that you can think of are all going to be inter-networked together. Now the question is that how you are going to inter-network? They do not have any intelligence, they do not have any life, they do not have anything. They are like dummy objects. How you are going to do that? So it's a very interesting thing. So we can all inter-network, we can connect them, we can make them more intelligent than being the dummy objects by using something called the embedded systems technology. So we can basically deploy different individual embedded systems in each of these different physical objects, and these physical objects, they can essentially if you deploy the proper embedded systems, then they can sense, these physical objects can sense whatever is going on around them depending on the sensor that is deployed on these objects. They can communicate with one another because of the existence of some kind of a communication module. They can do some little bit of processing that is also possible, so some small computations can be performed. And the beauty is that all of these different objects, these different physical things, so so through their collaborative nature, through their collaborative communication, they can basically collectively they can get a lot of data which could be used, which could be mined in order to get a lot of intelligence or a lot of insight about whatever is going on around these different nodes that are deployed around them. So you see that so this is a very attractive thing, right? So let me just try to give you an example which will illustrate the beauty of IoT. So people are nowadays talking about smart cities. I think most of you have heard about the smart cities. People are talking about smart homes. That also I'm sure that many of you have heard about. So let us talk about a smart home. So whenever you are talking about a smart home, quite likely that you will have to use IoT devices and IoT systems deployed in order to make your home smart. So how do you make your home smart? So you have to deploy different IoT devices and you have to interconnect them together in order to make your home smart. Now, a smart home might be having a lot of different sensor-enabled nodes. Sensor-enabled nodes, like there could be sensors like temperature sensor. There could be lighting sensor. There could be there could be even cameras. There could be accelerometer sensor. There could be gyroscope and so on, right? So what happens is, if there is an elderly person residing in a smart home, and if that person falls down, then you have adequate sensor-enabled nodes throughout the house to basically not only detect that the person has fallen down and inform the corresponding caregiver of that person, but also it can take some requisite step. It can do beyond not only detecting and informing, but also it can take some kind of some steps might be taken. For example, it could be, there could be some kind of a robotic device, a robotic arm or something of that sort, which can come and assist that person who has fallen down, the person in need, right? So as you can see that doing all of these require a lot of sensing, lot of collaboration between these sensor nodes, a lot of computation will be involved, and they not only will have to be involved, but also so these computations will have to be done in real time or near real time in order to be able to derive meaningful benefit out of these systems. So IoT is basically a seamless connected network system of embedded objects or devices with identifiers in which the communication without any human intervention is possible. So let me elaborate this part. So communication without any human intervention. So ideally these systems, whether you are talking about a smart home, or whether you are talking about a smart parking, or whether you are talking about anything else which is smart, it is quite likely that the system will be completely devoid of any kind of human intervention, or so at least it will be partially, right? So semi autonomous.
Excuse me, sir.
Yes.
Are you scrolling the slides? Actually, it is
Yes. Yes, I am. I'm switching
But
slides.
it is
What do you
only
see?
what is Internet of Things. It is stick on that slide.
Yes, I'm on that slide only.
Okay, sure, fine.
Yeah. So yeah, thank you. Yeah, so this is what, right? So this human intervention is a very important thing, right? So there should not be any human intervention. Ideally, there should not be any human intervention. Autonomous, fully autonomous, or partly autonomous, right? So full autonomy is something that people try to achieve, but it is still not possible. So at least people try to get some partial autonomy in the system. So these autonomous systems, basically they have a lot of properties, right? So how do you how do you make them fully autonomous? So these systems, they will have to self-configure. So with without any human intervention, they will have to the nodes, they will have to configure themselves and make them operational. Self-configure. There is something called self-healing property. Self-healing means, like, if some node has broken down or some link has broken down, basically. These systems should be such that they should be able to still work in the presence of any kind of fault, right, with adequate levels of quality of service guarantees. So this is basically self-healing, like this, actually self-managing, self-optimizing. A lot of different self properties are there. Okay, so this is basically what people try to build. They want to build IoT systems which are completely fully autonomous, or to a large extent so. So you see that what we are talking about smart home, smart home, smart city, right? So if you are just talking about one smart home, how many sensors will be there? How many sensor nodes? How many network nodes are going to be there? Probably some few hundreds, right? So one home, if you want to make it fully smart, you are talking about few hundred nodes. Now in a city scale, where you have tens of thousands of homes in it, if you want to make that city smart and having all nodes, all homes which are smart homes, then you can understand that how many such sensors will be there in a particular city. And not only homes, in a city you have, like, public places, like, roads, or you have different installations like traffic lights, and you have regular the street lights and so on. So many different. So if you want to deploy these nodes, so how many nodes will be required? Too many nodes will be required. So too many nodes, too many sensors. So how you are going to, so as you can understand that when transitioning from the regular internet to the internet of things, basically, so you are exponentially, you are adding to the number of connected devices. So it's basically exponentially, it increases, the number of connected devices increases. So many devices have to be connected. Now you see that from a network point of view, already we were landing up in trouble when we were increasing the number of connected computers, right? So we, for example, with addressing itself, IPv4 based addressing was becoming insufficient. People started talking about IPv6. IPv6 also has its own limitations. So you see that addressing is one issue. Like this, if you are talking about, let us say, the network throughput as a whole, throughput itself is also going to be affected if you are increasing the number of nodes, right? So there are a lot of theoretical results which show that throughput basically decreases at the rate of 1 over square root of n, where n is the number of nodes in the network. So there was one paper, if I remember, it was in the year 2002, where a couple of researchers from the US, they published a paper in IEEE Transactions on Communication, where they had shown that the throughput basically decreases at the rate of 1 over square root of n, where n is the number of nodes in the network. So as you can understand that if you are increasing the number of nodes, the throughput itself is going to go down drastically. Okay, so from 2 nodes to 4 nodes, from 4 nodes to 8 nodes, if you are increasing, the throughput basically drops even faster than this increase. So how do you handle this kind of complexity in terms of the performance of the network? And at the same time, in IoT, when you are talking about IoT, it is quite pertinent to think about millions and millions of devices being connected together, right? So, and it's all one network we are talking about. How you are going to connect them, how you are going to manage the overall efficiency of the network, what about the scalability, what about addressing? So many issues are there. So this is where a lot of research basically on IoT and IoT networks are being done around the globe. I hope it is clear. Any question? So that's about what IoT is. So this complexity is that due to the increase in the numbers, we are gradually getting into a world where the number of connected devices will far exceed the number of humans on Earth. Already, this break-even basically took place in the year 2008, where there, were more number of connected devices than people. This world. Now, at that time, we were talking not about IoT, we were talking about computers only. And now with IoT, we are talking about trillions of sensors being used in billions of smart systems, which are supporting millions of applications, all using IoT, right? So how it is going to be possible? So we are going to, so it's a very complex system that we are talking about. And you have to come up with network-based solutions. You have to come up with other solutions will also be required, but at least the networks based solutions are primarily very important if you are talking about this kind of complexity. Now, earlier I was mentioning about the smart city, right? So among the participants, could you tell me how many smart city projects the government started a couple of years back? Our government, Indian government. Anyone from the audience? So 100 smart city projects, right? 100 smart city. So it started with the 100 smart city vision. Then it, so it started with couple of, in different phases it happened, right? So it started with, couple of smart cities initially. Then the numbers were increased. So gradually, actually, one after the other, the number of through the different phases, basically the number of cities that were considered for smart city, transitioning to smart city, that basically kept on increasing. So in a smart city, basically, this is what, so the picture that you see in front of you is a schematic of the smart city in any smart city. So any smart city basically has smart traffic monitoring, smart surveillance, smart parking, smart different e-government services, right? So different city services, different government services, all available, through the internet, all connected together. You right from your home, right from your office, right from your desktop, you should be able to get all your services that you want. So a smart city basically also has smart energy management, pollution monitoring, transportation, so healthcare like hospitals, smart hospitals, and many others. So everything has to be smart. So how you are going to make them smart? You have to make them sensor enabled. You have to make them sensor node enabled, IoT node enabled. So you are going to have an IoT network which is going to be deployed in order to make a particular city smart. I'm not sure how many of you have visited the the smart cities, right? So I'm sure that you have seen smart cities, you have lived in smart cities, but how many of you have seen actually already experienced the smartness in these smart cities and the different types of experiences? I'm not sure how many of you have that. So, but I believe that over here you have difficulty in speaking, so I'm going to skip that part. But so as you so let me just share my experience. So one of the smart city projects that I liked was that from Naya Raipur. So Naya Raipur is situated about 40 kilometers, 50 kilometers from Raipur, right? So Naya Raipur basically it is not the actual Raipur. It is little away from the main Raipur. Now, this Naya Raipur was made a greenfield city, a smart city. So greenfield means from scratch. From scratch, basically, you are developing a smart city, right? So it was a barren land. Nobody was using that land, and people started building a city in that particular locality. So, so there are actually two types of smart cities. One is called this greenfield cities. The other one is called the brownfield. Brownfield means like you already have a city in place. It is operational. It is functional, and then you try to gradually evolve that city to make it smarter, right? So, for example, Kolkata. Some parts of Kolkata is part of the smart city project. So, Kolkata and the parts that are part of the smart city. So these are all, these have been existing since several decades, right? So what you have done is that you have taken some part of the city and you have tried to deploy these smart services to the citizens for the improvement of the life of the citizens. Okay. So when you are talking about, like smart city, etc., you have to talk about governance. Need to have smart governance. If there is agriculture, then it has to have smart agriculture. There has to be smart living, smart people, smart economy, smart mobility, smart environment, and there are so many different other components of the smartness there. So all will be powered with the help of IoT and IoT networks, right? So all of the smartness means that quite likely that you need to have strong doses of IoT involvement in them. Okay. Now, this address crunch I was talking about earlier, that right in the year 2018, there were about 20 to 50 billion devices. So you had to integrate all these existing devices. You have to bring them all under a common platform. And so how it is going to be possible? So apart from the issue of address that I told earlier, so if you are increasing the number of devices, you also have to increase the number of addresses that will be used to identify these devices. So IP-based addressing, particularly IPv4, it was not very suitable. So people have been working on, people who are doing research on IoT. So some of them, they have been focusing on the addressing aspect. So people have been talking about that, can we for IoT, can we have a completely different type of addressing mechanism, not the IP based addressing mechanism? So there are a lot of consortia. There is an European consortium. There is an US based consortium, so which have been looking into the issue of addressing different, completely different type of addressing for IoT. Now, so what happens is that these addresses, so you cannot use the same kind of IP based addresses, right? So you need to have some. So you have to have some addressing mechanism which will support this scalability. So then people thought about there is something called attribute based attribute based addressing. So basically, based on the different attributes of an individual, of an object, basically, so those will be used in order to identify those objects. So it becomes a completely different thing, right? So IPv4 is different, attribute based addressing is different. Like this, actually there are different other addressing mechanisms that people have been researching on. So when we talk about IoT, still we do not have a single standard for IoT. We do not have one standard. So unlike internet, right? So regular internet, the standards that are used is basically OSI, or better is TCP/IP architectural reference, right? So those are used. Now in IoT, actually you do not have any kind of similar kind of this architectural framework. You do not have that. You do not have an OSI. You do not have TCP/IP. So people have been thinking about that, how to build IoT systems. So one possibility was that you extend your existing internet. Think about these different sensor enabled nodes as extensions to the existing internet. So this is one possibility. The other possibility is that you can you can build the internet from scratch. From the IoT system from scratch. You can build the IoT system from scratch. So one is an extension of the internet. The other one is that you can build the IoT system from scratch, right? So again, there are different there are different propositions about how you are going to build an IoT system from scratch and not extend just the regular internet. So so there are different frameworks that are available. So one of the common things, basically what almost every framework talks about, is these layers. Basically, at the very bottom you have the sensing layer, and on the very top you have the interface layer, and in between you have the network layer and the service layer. Now sensing layer basically talks about sensors, sensor devices, and so on. Network layer is a bit different from the network layer that you have encountered in OSI or TCP/IP. So here actually this network layer corresponds to the different networks like wireless local area network, wireless sensor network, cellular network. These are actually networks which are part of the network layer. Then comes the service layer. So IoT is all about services. Service centricity is very important. So there is a separate layer which is called the service layer. And on the top you have the interface layer or the application layer. So this is basically very similar to the application layer that we all know for the regular internet, right? So it's very similar to that. So all the different applications, the APIs, these are actually part of the interface layer. So this is what I was telling you. So please have a look at this particular figure. At the very bottom, you have the sensing layer comprising different intelligent sensors, RFID readers, RFID tags, BLE devices, and so on. So these different devices, they continuously sense the physical phenomena that are occurring around their hosts. They acquire the data and they send higher up, right? So then comes higher up, then comes the network layer. So network layer, basically you are talking about different networks, as I was telling you, that wireless sensor network, mobile networks, local area network, wireless local area network, social networks. Social network is also part of the network layer. So these are actually part of the network layer. Then the service layer, here you are talking about issues of service integration, service division, so all of these are part of the service layer. And on the very top, you have the interface layer, where you are talking about applications, application front end, APIs, contracts, interfaces, and so on. So all of these are part of the interface layer. And cutting across all of these vertical layers is the issue of security. So basically what it means, you look at this particular figure, you see that the vertically security is part of all of these different layers. It is cutting vertically across. So vertically across means like, so security is part of the interface layer, security is part of the service layer, security is part of the network layer, security is part of the sensing layer. Okay. So right when IoT was evolving, right when the sensor networks was evolving, at that time, another technology which was becoming very popular was cloud computing. Now, as you know that IoT is very much data intensive, sensor networks are data intensive. So basically they are very good in terms of the acquisition of the data, in terms of the sensing, in terms of the acquisition of the data. These networks, IoT networks or sensor networks, these are very good. Now, after you have acquired the data, how do you process the data? What do you do with the data? You process, you store. So how do you handle that? So one possibility is that traditionally what people used to do is to dump everything on a server, right? You connect to your existing internet and you dump everything onto the server. But with the evolution of the cloud technology nowadays, I think almost every IoT implementation that we know of basically uses the cloud. Even like student projects also nowadays, they are using some cloud. Cloud technologies like ThinkSpeak, AWS, etc. So all of these will be used in order to store the data and process the data. So IoT is good for data acquisition, right? Sensor enabled devices. So you have data acquisition; they are very powerful in that. And for the processing of the data and the storage of the data, what you need is the cloud framework, right? So this integration, IoT and cloud, if you integrate both of these technologies together, you are going to get an end-to-end robust system. IoT networks basically are strong in terms of data acquisition. So you get a very strong data acquisition in place. And because cloud computing framework is very good in terms of processing and storage, so you get a very powerful processing and storage mechanism. So we have an end-to-end very powerful data acquisition to storage processing kind of framework with this integration of IoT and cloud computing. Okay. Now, cloud basically, as you know, there are different cloud models, different service models. These are called the infrastructure as a service, platform as a service, and sensors, and software as a service, right? So these are basically well known in the community now. Everybody knows about cloud computing. Everybody knows about infrastructure cloud. Everybody knows about platform cloud. Everybody knows about cloud, right? So these people, not only we know, we are all using. So most of the Google features that we are using, the software that we are using, these are actually all mostly like software based cloud. Although, so you also have Google infrastructure cloud and all of these things. So what I want to emphasize over here, that cloud computing has become more or less, part and parcel of everyday life, right? So consequently, what happens is that you have with cloud, you have features of very powerful storage and processing. So out of processing, you have analytics. So you can run very powerful analytics on these systems. So now you think about an end-to-end IoT cloud computing framework where data are continuously being acquired and streamed continuously. And that you are streaming all the data onto the cloud, and at the cloud you are continuously processing the data. So you can have analytics of different types, real-time analytics inclusive, which can be performed on this integrated IoT cloud framework. So if you remember that little while back, I was talking about the features of autonomy. I said that, so these have basically borrowed different features of autonomy from autonomic computing. Computing became very popular from some of the white papers by IBM. So and that was several years back. So many of these features of autonomic computing have been adopted in IoT as well. So nowadays people are talking about fully autonomous IoT systems where self-adaptation, self-organization, self-configuration, self-healing, self-prescription, self-optimization, and so many different other self-properties. These are actually attractive and essential properties that the developers of IoT systems are trying to induce in these systems. So what are the different building blocks of IoT? So typically in the same way as in the internet, in the internet, what do you have? You have the network node, the proxy, the gateway, the local area network, the wide area network. Here also you have the similar kind of building blocks for IoT. Very similar. So in the same way as you have an IoT as a internet node, here also you have an IoT node. In the same way as you have an IoT regular LAN, local area network, here also you have IoT LAN. So these are actually the different building blocks. So what are the different enabling technologies? Let us go through some of these different enabling technologies. So wireless network, right? So we have to understand the wireless. Everything nowadays that we think about, that we know in IoT networks, basically, mostly it doesn't have to be, but mostly, basically, it's all about wireless, different types of wireless networks. Now, if you look at wireless networks, we all are using wireless networks. Mobile phones are a good example of wireless networks, right? Connecting to Wi-Fi, that is also a good example of wireless network. So like this, actually, not only mobile phone and Wi-Fi, like this, actually, there are so many different advanced wireless systems, communication networks that are available. Things like Bluetooth, many people are using Bluetooth. Things like Zigbee technology, many people are using Zigbee. So like that, actually, there are so many different ones that are available, supported by different standards. For example, traditionally there was 802.3, IEEE 802.3, 802.5, 802.11. Even within 11 also A, B, G, C, etc. So a lot of different variants are there, right? So 802.11, then came 802.15.1, 15.4, 802.15.6. And so then came 802.16. Like that, actually, there are so many different types of standards that have been come out in order to build different wireless systems. Okay, so for when we are talking about IoT, mostly what people work on are basically low power networks, low power systems, low power devices, and so on. Because these are like, IoT nodes are very small in size, right? So if they are small in size, the battery that is being used to power that node, that is also very small in size. And due to the limitations of the electrochemical efficiency of these batteries with the size, so if the size of a battery is small, the electrochemical efficiency of the battery is also small. If the size of the battery is big, the electrochemical efficiency of the battery is also big. So because of all of these different limitations, basically, most of these IoT nodes, these are very small in size, and they have to not only they have to undertake a lot of processing, but also they have to be, so they have to do all of these by taking care of the energy. So these have to, they have to be energy aware. So energy aware computing, energy aware networking, energy aware wireless networks, these are the important things that are coming up. So infrastructure, so now these wireless networks, if you think about, like the cellular network, Wi-Fi, ad hoc network, sensor network, social networks, like that, actually, so many wireless networks are there. So all of these different wireless networks, you can broadly classify them into two categories. One is called the infrastructure based, the other one is infrastructure less. Now, this cellular network, Wi-Fi, etc., these are actually part of the infrastructure based category. The infrastructure less category, you have the sensor networks. So ad hoc sensor networks are actually part of the infrastructure less category. So this infrastructure based and infrastructure less, these two different types of wireless networks are available, which are used quite extensively in IoT networks. So as I was telling you by introducing myself, I told you that in my initial years of research, I used to focus more on the ad hoc networks, and that was like more than 15 years back. So at that time, people didn't talk about IoT networks and so on. People used to talk about ad hoc networks, and then after a couple of years, people started talking about ad hoc sensor networks, or just sensor networks as it is called. So in these ad hoc networks, basically, these are, like as I said, that these are infrastructure-less networks. So you do not have any fixed access point. You do not have a centralized network manager. So basically, so when you have to form a network in the absence of any kind of an existing network infrastructure, and you have to set up a network very fast. For example, in times of emergency or relief operations. For example, so many times, there are different types of attacks, right? So different types of attacks. These are like man-made attacks, but there could be some natural vulnerabilities also, like earthquakes and so different other flood, earthquake, etc. So whether it is natural calamity or there is some kind of intentional man-made kind of attack. So what is common is to lose the existing internet, right? We have seen, like, when you get a heavy rain, right? Even in nowadays also we must have seen, like with mobile phones also, whenever there is heavy rain, basically network goes down for some time, or the signal is very poor or something like that, right? So whenever you do not have the existing network, or the existing network has basically it doesn't perform due to some kind of some kind of natural calamity or something, so due to some kind of event. So at that time you have to set up the network pretty fast, because for example, after an earthquake, the rescuers, the relief persons, they will have to carry on with the relief operations in the rescue. So they have to communicate with one another. So in order to communicate with one another pretty fast, these ad hoc networks, these useful because you do not need any fixed infrastructure setting them up. So you simply have a collection of different nodes. You put the nodes together, they start communicating with each other if you have basically configured them in a certain way, right? So, so these ad hoc networks are an attractive choice for building IoT networks. Similarly, another type of network, which is a close cousin of the ad hoc networks, is called the wireless sensor networks. And these wireless sensor networks are also very important. And in fact, I feel that most of the IoT networks, sensor-enabled IoT networks that we talk about nowadays, these are actually belonging to the category, the classical category of wireless sensor networks. Wireless sensor networks. So these wireless sensor networks, they consist of large number of sensor nodes that are deployed in a particular area of interest or terrain, right? And these sensor nodes are capable of collaborating with one another. So basically, what happens is that these sensor nodes, they will be, different sensor nodes will be sensor equipped, and they will be collaborating with each other. And each of these nodes is going to measure the surrounding environments with respect to light, with respect to temperature, and so on, vibration, etc., and so on. These sense measurements are then transformed into digital signals and processed to reveal some properties of the phenomena around the sensors. And due to the fact that the sensor nodes in these networks have very short radio transmission range, I already told you that these are very small nodes. So small nodes, small size nodes with small batteries, they have very small, this communication module. So small communication module. So if you're talking about small communication module, you have very limited sized antenna. So not only size, but also the antenna capacity is also very limited. So if you are talking about such a system, basically, then they are all going to have a very small, a short radio transmission range, right? And if you have, if the nodes, they have to communicate with each other, and because of the fact that these nodes, they have very short transmission range, so you then to take help of the intermediate nodes in order to send the packet from the initial source to the destination node, right? And so the nodes through which it travels, it's part of the multi-hop path, right? So you have multiple hops through which a packet from the source node will have to go to the end node, right? So in node means like the intended destination node. So multi-hop, right? So multiple hops are there in the path. Wireless sensor networks, they are of different types. One is called the stationary. So far, whatever we have been talking about, we have been assuming that these are stationary, but you could also have mobile sensor networks. So where these nodes, which are sensor equipped, they actually move. Irrespective of which type of sensor node you are talking about, most of these sensor nodes and most of the IoT nodes also, they have these common units, right, which are there almost in all the nodes. So they have a sensing unit typically. So there will be some kind of a sensor. They manufacture a fabricated sensor which will be equipped with this node, right? They have a sensing unit. They have a processing unit. They have a processing unit means that there is some kind of a processor in place, right? So there are different processors nowadays that are there. People are using open hardware platforms like Arduinos, Raspberries, etc. They have their own different processors. They have microcontrollers. So they have some kind of a processing unit, and then they have the transceiving unit. So there will be a separate module, a transceiving module. So let us say Wi-Fi. If you have to communicate over Wi-Fi, the nodes have to communicate with Wi-Fi. So basically, there will be a Wi-Fi module. There will be a Zigbee module, and so on. There will be this power unit in order to power the different nodes, right? Additionally, there could be some optional units like some application dependent units, mobilizer unit, location finding system unit, and so on. So this is basically the schematic of most of the sensor nodes that we talk about, right? Not only sensor nodes, basically IoT nodes. These sensor nodes, they have different sizes and they have different shapes. So in the picture that you see in front of you, you can see these different types of shapes of these sensor nodes and the different sizes. So typically with respect to the different reference points, as you can understand that are very small in size, and they are particularly small in size if they have been fabricated with the help of MEMS technology, microelectromechanical system, like MEMS technology. MEMS-based sensors are very small in size. Nowadays people are talking about nano electromechanical systems. NEMS will make the nodes even more small. So these different sensor nodes, they come in different sizes and shapes. They have very small, short transmission range. They have a small operating system. So there are so many different sensor node operating systems. One of which is called the TinyOS. So this TinyOS is a very powerful and very popular operating system which is used in these sensor networks, in these sensor nodes. and these nodes are battery powered, as we have seen previously. So there are different types of applications that are supported for environment monitoring, temperature, humidity level, lighting condition, air pressure, soil makeup, noise vibration, noise level, vibration, and so on. So many different types of applications are there. And on the on your right hand side, you see some of the different pictures which will show you pictorially, quite evident the different applications that could be supported by these wireless sensor networks. So one of the important applications of wireless sensor networks is in healthcare. So post-disaster healthcare, for example, after there is some kind of an event, right? So so there is, let us say that there is some kind of a terrorist activity, or there is some kind of earthquake or anything, right? So if there is some kind of an event, it is quite likely that many people will be dying, many people will be injured, many people will need to go to some kind of a hospital or something like that. So as you can understand that close to the site of the event, so wherever people are getting injured, it is, if there is some kind of a medical facility, these patients will all have to be brought into that medical facility. And so if you are bringing all of them, then how do you monitor, right? So typically, most of the, if in our country, if we are talking about a public healthcare facility, sorry, not public, it is called primary healthcare facility, like in the villages, etc., the primary healthcare centers. So in a primary healthcare center, you have maybe one or maximum two doctors, 2 or 3 nurses, and so on. So if you even if you are talking about a city-like environment, there also the medical facilities that are there, and also the personnel that will be there. These are all going to be very limited. So how you are going to deal with this? How you are going to deal with this? So for this, actually, this kind of an application that you are seeing, with the help of different sensor nodes that are deployed, these could be used in order to continuously, efficiently monitor all the different patients that require the medical attention at the same time. Otherwise, manually, if you have to do it, then it is going to be almost impossible in order to get to this kind of problem. So sensor networks are very popular. IoT networks are very popular, but there are many different common challenges that are there. Scalability, I already told you that it can be shown that if n is the number of nodes in the network, the throughput of the network increases at the rate of 1 over square root of n, where n is the number of nodes in the network once again. So if you are increasing the number of nodes from 2 to 4, 4 to 8, 8 to 16, and so on, the throughput is going to go down much more rapidly than the increase in the number of nodes in the network. The issue of scalability is that not only throughput, but also any other network quality of service parameter, you will have to offer some kind of a guarantee to these different networks in terms of scalability. Okay? You have to some kind of acceptable levels of service guarantees will have to be provided to the stakeholders, right? So quality of service is there. Quality of service basically talks about offering guarantees in terms of bandwidth, delay, jitter, packet loss probability. Already these channels, they have very unpredictable changes in their characteristics due to the regions where they are deployed. Typically, they have very limited bandwidth and so on. So how you are going to basically deliver some kind of a guarantee, offer some kind of a guarantee in terms of service, okay, quality of service, in the presence of these kind of different challenges in the environment and the channels. Efficiency is another very important issue. Nodes, they have very limited battery power. These nodes need to cooperate with other nodes for relaying their information. So so why they are going to cooperate? Because if they have to cooperate because you are talking about multi-hop network. Unless the intermediate nodes, they cooperate with the other nodes, the are not going to be delivered forward. So these nodes, they have very limited battery power, and they need to cooperate with other nodes for relaying their information. So how energy is going to be utilized, right? So energy efficiency is very important. Security is very important. You are talking about the open medium. The nodes are prone to malicious attacks, infiltration, eavesdropping, interference, and so on. So how do you handle these different issues. Okay, so I think if possible, let us take a break of 5 minutes, and then I'm going to come back and cover some advanced topics on IoT. So these are some of these common basic challenges, and we can take a break of 5 minutes if it is okay, Professor Samad.
Yes, sir.
Yeah.
We can
So,
have questions now, and
yeah, we
you
can take 1 or 2 questions. Yeah, and
you
then
can
can take a
pause.
break and we can come back.
Sure.
If there is any question, please feel free to ask. Is there any question?
That someone is asking, any real-time example of combination of ad hoc networks with ML modeling?
Everybody wants to get into ML nowadays. so real life, I think you are talking about the I mean, whoever has asked this question is not talking about real time but real life. I think real life example of integration of ad hoc networks with machine learning, right?
Machine learning, right?
Yes. You see that it is a very important thing. So first of all, ad hoc networks, let me again tell you that ad hoc networks, pure ad hoc networks are no longer popular in terms of research. So why I'm telling you this thing is that if anybody actually wants to start a research problem, then working purely on ad hoc networks may not be very interesting. But in case you want to work on, let us say, pure ad hoc networks, so ad hoc networks, so let us say that I was earlier talking about surveillance, right? So surveillance using ad hoc networks, so you have, let us say, different cameras, right? Small cameras that can be integrated with IoT nodes. These are all popular, right? So how you are going to, so if you are talking about cameras, then you need to have uh, not only real life but real time. Actually, you need to have real time processing, right? So you need to have real time processing of the video streams that come through, because surveillance is something where you cannot really wait for doing the processing. So you send everything to the cloud takes 2 hours in order to give you the result. So that is not good. So as and when streams of frames come through, so you will have to do the processing, and you will have to get some insight into what is going around the cameras which are deployed in the network, right? So machine learning innovations will have to be there. So what is the main problem with machine learning algorithms is that these machine learning algorithms, they need huge computational resources. They need huge computational resources. Now, in a constant environment like an ad hoc network, how you are not going to have any huge resources. So you cannot really think about in an application like surveillance. You cannot really think about dumping all the data, the streams, to the remote server or the cloud. So it is not possible. So how you are going to do some of this processing close to the source, which is called edge intelligence nowadays? So how you are going to do the processing over there? That is very interesting. So what I would think is, if somebody wants to get into this kind of research, right? So machine learning applications for real time processing of video streams coming from from a camera connected to an ad hoc network, this is something that one can explore, right? So like this, actually, there are different other examples where um, where real-time processing would be required, right? So for this, actually, as I was telling you, that fog and edge intelligence, edge computing, these are very important. Okay. So when we are talking about machine learning, people are talking about different other things like distributed learning, right? So federated learning is there, distributed learning, then resource constraint machine learning. So resource constraint machine learning is basically in cases like ad hoc networks, there are resource constraints, right? So these are like, they have very small battery, they have very small processing capability, etc. So there is one area of research which is called the resource constraint machine learning, where people are talking about how you can use these machine learning algorithms, how you can innovate in terms of the applicability of the machine learning algorithms so that they can run on resource constrained devices. I hope that this serves to some extent, this answers your question. Any other question?
Let me see on the chat.
Yeah, let me see. Interface also.
Attendees, if you have any questions, please.
Yeah, you can just ask. Right. So, okay.
What
I'm
about
not able to get the chat box somehow. From my
what
interface.
about ESP boards?
What about means, what do you want to do with the ESP board? ESP
Uh,
modules are very much used, right? So most of these prototype implementations basically use ESP nowadays, right? So, but mostly these are for prototype implementations. Prototype implementations of IoT. ESP modules are, very much popular already.
How IoT is going to help smart agriculture and smart delivery of public services in rural areas?
Yeah, that's a very good question. Actually, the main problem with rural areas is the connectivity, right? So everything else almost remains the same. So smart governance, smart agriculture, so all of these, what you need is some kind of proper connectivity. Backbone connectivity has to be there, right? So IoT, first of all, there are so many rural applications, like as you said, agriculture. Typically in our country, it is rural, right? It's a rural activity. So whether it is agriculture or whether it is, so like nowadays people are talking about smart villages, right? So all of these basically, there are a lot of attractive applications in the rural areas, but so what you need is the connectivity. So how you can address this connectivity issue if you have proper connectivity in place, and so coming up with different applications, interesting use cases, that definitely one can do. Any other question?
Someone is saying that computer-based students, is there any requirement for electronics to understand IoT? And he is also saying that I already developed an IoT system in my home using those modules without IFTT. Can I search in this? Can I research in this field further?
Yeah, so in for example, in my lab, not everybody is an electronics engineer. They do not have background in electronics, but they have background in computer science or IT, right? So definitely, because of the availability of these open source hardware platforms like Raspberries and Arduinos and ESPs and so on, basically, so nowadays you don't need to be an expert in electronics. You do not really need to design an electronic circuit. Of course, eventually if you have to commercialize something or like that, you need to get into that. You need to design your circuit boards and so on. But I think mostly, and so many resources are available nowadays on the internet in order to work with these IoT platforms. Basically, so you do not need to have an electronics background to work on it. You can come from any computer science or any other relevant background, and you should be fine.
Is IoT simply dealing with sensors?
So sensors, actuators are an integral part, right? So it doesn't have to be. So IoT doesn't mean that all nodes will be sensor enabled, right? But typically, when we are talking about, otherwise it becomes the plain existing internet. So whenever we are talking about IoT, typically, we are also assuming that there is some kind of a sensor or some actuator or a network of these devices which will be used, right? But yes, it doesn't need to be necessarily using any kind of sensor. It doesn't have to be sensor equipped, right? You can have IoT without any sensor also, theoretically. But practically, actually, mostly, these nodes, they have some kind of sensors.
Sir, a student of master is asking how to join your lab for research.
Yeah, so if you have already completed your master degree, so please,
No, he's in final year.
yeah, so even if you are in final year, so mostly our openings are for PhDs or postdocs, right?
Okay.
So only IIT Kharagpur BTechs, right? They can work in our labs, BTechs and MTechs. But during the summer, typically we also take couple of interns. So if you are interested, next winter, actually you can. I mean, this summer it is not possible anymore, but coming winter you can send me your CV for being considered for uh, an internship program. But I think so if you are a fourth year student, then this may not be relevant for you. Anything else?
No, sir, I think it's over. You
Okay.
please continue.
Yeah, so let us take a couple of minutes, 3-4 minutes break, and we'll come and complete the rest of the stuff.
Okay, okay, sure, sir.
Okay. Now, let me see how to. So this platform WebEx somehow confuses me a lot. Anyway, so let me, and I will log in once more. Yeah, I think that is the best.
Sure, sir.
Now I can see it. Okay, so then I will simply keep myself on mute and come back.
Okay, sir.
Okay, Professor Samad, I am back.
Yes, sir. Welcome.
So
There are one or two more questions. Let me see. What are the various resource allocation techniques in IoT?
resource allocation is a, so I think the student is basically getting into whoever has asked the question. So resource allocation basically, so it's a topic of research, right? And there are so many resource allocation, people who are working on research allocation research that is going on. So it's difficult to summarize like this, but yeah, this it's an activity of research.
Actually, they are asking, can we design a novel array technique in IoT?
Of course, why not? So if it is an active area of research, it means that there are definitely a lot of solutions are already there. A simple search in the internet will give you plenty of research that is going on this thing. But yeah, so because it's an active area of research, definitely resource allocation is an important problem, and people definitely can come up with some novel solution for it. Yeah.
Okay, fine, sir.
Anything else?
No, that's it, sir.
Okay. So let me just continue from where we left.
Yes, please continue.
So,
Slides are visible now, sir.
yeah. So now let us look into the implementation. So far, actually, I think many of the participants are already familiar with IoT from the nature of the questions that are asked. I think some of them they are already aware of this thing. But for the sake of completeness, let us look at how a simple IoT-based system can be built. Right. So you do not really need to procure any hardware. Like you can build a very simple IoT, very simple IoT system with the help of your smartphones. So every smartphone, as most of you already know, they come with different sensors, right? So typically like accelerometer sensor, temperature sensor, gyroscope, etc. So all of these different sensors, most of the smartphone sensors nowadays they come with like 3 to 7 sensors typically. So what you can do is like with only one smartphone, and the sensors that are there in them. So you enable the sensors, you turn the sensors on, and the sensed data, you can pump the sensed data through the internet to a remote cloud server. Okay. Now let us say that continuously you keep on measuring the accelerometer data, accelerometer sensor data of your smartphone, and you keep on dumping it onto your cloud server. Now, with that simple one sensor value, if you analyze continuously over like the time series data, if you analyze, then you can make a lot of sense out of what is going on around that smartphone, right? A lot of things can be done. So for example, accelerometer data can have been used in the research literature for detecting fall, right? If somebody who holds the smartphone falls down, right? So if somebody falls down, the accelerometer data been used to detect the fall, right? So accelerometer combined with gyroscope, that basically we can give you even more precise information about the happenings. Okay, so like this actually there are different sensors which you can use in order to analyze the data that are coming in from the sensors, analyze them on the cloud, and then feed the result back of the analysis that from the processing that is done on the cloud. The results of the analysis could be fed back to the source itself, to your mobile phone itself, right? So this is what is depicted in this figure in front of you, and this is a very simple toy implementation of IoT that you can do with nothing but your smartphone, only your smartphone, right? Another thing that I often give as the first project to the students of my IoT course is to do something like this. What they do is that here actually you need to procure few accessories, few electronics, few hardware. So you can very easily you can build a sensor node, right? This sensor node comes with it, any kind of sensor that you want to install on the node, a processor, right? Some microcontroller or something, and the communication unit, right? Typically XB or whatever. So depending on, let us say, if you want to use Wi-Fi, you have to use the Wi-Fi module. If you want to use Zigbee, you have to use the Zigbee module, and so on. So like that, these are actually all publicly available. You just procure them, put them all together. There are so many different tutorials on the internet how if you want to put them together, how you can put them together very easily. You can do it. It's not difficult at all. So you can, like this, you can build a very simple sensor node in this manner. A sensor node having a sensor unit, processing unit, and the radio unit. So this node, the moment you turn it on, power it on, it will start sensing depending on the type of sensor. Let us say that you have, it's a proximity sensor, let us say, right? So if there is some, some object which is in its proximity, it comes in proximity, then, it will immediately send the signal. That signal will be sent to the cloud server, right? So the information will be sent to the cloud server. On the cloud server, the required analytics will be done. So there will be some, some algorithm, something, some logic, some intelligence that will be executed, and finally there could be, so you can, based on the analytics, basically you can actuate something, right? You can actuate something. So actuate means what? You can turn on something, right? So if you are talking about, so let us say that you are talking about a light sensor only. It's very simple. So light sensor basically will tell you like how many lumens are there. So so if you find that around the sensor node there is insufficient lighting condition, then automatically the bulb will be turned on, right? If you are talking, so here actually I have shown bulb, but the bulb you can have any kind of actuation. It doesn't matter, right? So so this is a very simple, like first experimental exercise that my students in my IoT course they do. Okay, simple IoT implementation. Now, again, let us go back. So somebody was asking about resource allocation, right? So like this, a lot of research actually is going on stuff where a lot of, theory is involved. One such thing is the wireless body area network. Wireless body area network also has a component of resource allocation in it, right? But the resource allocation problem in wireless body area network comes in different flavors. So I'm not talking about the resource allocation problem, but let me talk about wireless body area network itself. So as you can see in this particular figure, wireless body area network has different sensors, right? Typically, if you are talking about a single individual, right, like a patient or somebody, the patient has different sensors like body temperature, blood pressure, ECG sensor, etc. So all of these different sensors, they all will be connected together. They will be typically like a star topology or something like that. And all these sensors, they are going to send continuously their data to the local processing unit, LPU. This LPU is typically carried by the W-band itself, or it is in very close proximity to the W-band. So this LPU could be a smartphone, the LPU could be a tab or something like that, right? So the LPU receives the data, and then through the communication channel, to the external communication channel, like let us say Wi-Fi or something, the data are going to be sent to the remote server, and in the remote server the processing is going to happen, and the results are going to be sent back to the intended stakeholder for further action. For example, if we are talking about patients, the results are going to be sent to the doctor or the nurses taking care of the patients, and so on. So like that, actually, this is called wireless body area network. Now, opportunistic wireless body area network is something where if you do not have the existing connection being there at certain duration of time, so opportunistically communication can take place. And this is very important, particularly in military exercises, right? Military, so like soldiers wearing different W band, or like in the battlefield, etc. So opportunistic connection establishment between the different nodes of a W band, or even externally also between different W bands, also opportunistically how the connection establishment can be made. Okay, so for this actually opportunistic networking is used. Opportunistic networking basically talks about that if your existing infrastructure, if your existing connection is lost, and if you are not able to set up a regular, proper, normal kind of connection with there, then opportunistically how connection can be established, so that the nodes they can communicate with one another, so that the devices can communicate with one another. So opportunistic connection establishment is a very important problem, and we did some work on this. Similarly, there are different other problems. Just to give you a little bit of flavor, as you can see, a lot of mathematics is involved, and in case you are interested, just search with my name in Google Scholar. You will be able to see my works on wireless body area networks. Okay, so other one is basically MAC frame payload tuning, right? So what happens is that you can improve the overall efficiency of the network, the performance of the network, performance of a wireless body area network by tuning the MAC frame payload, right? So for this, actually, we came up with an algorithm which can do it. This is the algorithm, this is the flowchart, and how this flowchart can be used in order to opportunistically improve the reliability in communication in these W bands. So similarly, other applications. So these are actually, I'm showing you like the different areas of theoretical interest where we have been doing a lot of research. So smart grid, I told you. So smart grid basically talks about that. Smart grid is like, how you can use the IT technologies, ICT, information and communication technologies, in order to improve your existing electrical grids, right? The performance of your existing electrical grids. So there are different, different aspects of research are there. One of the things that we worked on is pricing. Pricing, basically, we are talking about that how the different, how let us say that you are talking about a smart grid for electrical appliance monitoring in a home, right? So how you are going to, you utilize the different devices at your home in order to, what will be the pricing policy in order to basically make sure that not only the service providers but also the users both will be benefited, something like that, right? So that is basically the pricing mechanism. Research works on pricing. Okay, so like this, actually, smart grid, then opportunistic mobile networks, I already told you. Then UAV networks also, we did a lot of work on UAV networks. Here actually in UAV networks, you are talking about that unmanned aerial vehicles like drones, etc. How you can interconnect different drones in order to form different networks, like in the picture that is being animated. As you can see, different topologies could be formed: mesh topology, star topology, point-to-point topology. Different topologies could be formed when the drones, the multiple drones are on flight and they are in close proximity to each other. So the whole idea is that instead of using one drone, how you can use a swarm of drones in order to perform certain action collectively. Okay, so a lot of research is going on this. So this is basically a picture that I have shown you, point-to-point connection. So this is from IIT Kharagpur only. We have a helipad, and in the helipad, actually, we do a lot of our experiments on drones. And so I have also given the video link. So if you go to YouTube and search with my name or Swan Lab, right? So you will be able to get a lot of our experimental videos on drones, right? Networks of drones and so on. So this is one of these videos. From this link itself, if you go to this link, unfortunately you cannot click on it the way it has been given. But if you go over there, if you get one of those, from that actually you can get the other suggested ones, right? So we have done, so working with drones actually in real life is not very easy, let me tell you, right? So it's very attractive. Drone technology is very attractive, and a lot of potential exists. A lot of applications are there, But so we have been working on drones since last 6-7 years or even more, right? And I will tell you that it's a very challenging area. And particularly when you are talking about the networking aspect, flying a single drone, and if it is commercially available, that is one thing. But if the moment you are talking about a network of drones, it becomes very difficult, to have these kind of formations. Okay, this is basically some picture of one of the drones that we had built. Let me see. Just a single drone in flight from our facility. The second one. So they fly together and they are in connection with each other. So basically there is coordination between the different drones, right? Both of these drones, there is coordination and it's fully autonomous. Okay, so there is no human control. Nobody is controlling these drones. They are, being completely controlled on their own. Okay, so I think in the interest of time, let us go ahead further. So that is one thing. So aerial sensor networks, aerial IoT using drones. This is a very interesting area of research now. Another one which is very important is basically underwater, as I was telling you at the beginning, right? So underwater communication, underwater sensor networks. So what will happen, the same sensor network, same IoT networks that you are talking about, if you submerge the entire system underwater, conceptually if you submerge, right? Conceptually if you submerge, then what is going to happen? You cannot submerge, right? So because radio communication cannot take place underwater. So but conceptually if you do so, then how this communication takes place. So basically, so this is called underwater underwater wireless network technology, and underwater wireless sensor networks basically is our area of interest, right? So one of the problems that is very fundamental to wireless sensor network, underwater wireless sensor networks, is localization. Localization means like you have to localize the nodes that are underwater. Now you cannot localize with the help of GPS technology underwater. GPS, it's not like you install some GPS module, and this GPS module can tell you the exact location of the node. So you cannot do that underwater, unlike terrestrial systems. So how you can, in the absence of GPS, how you can localize the different nodes? So there are actually a lot of solutions that are there. This is actually one of a papers, IEEE transactions on mobile computing in the year 2015. Basically, we came up with a solution for opportunistic localization. Okay, so whenever it will be required, it will be opportunistically localized. Okay, so the nodes will be localized. So this is basically a solution that we came up with. I'm just touching upon. I'm not going through each of them in detail. Just to give you a little bit of flavor about the kind of research that exists. This is also part of this underwater sensor networks only, tic-tac-toe architecture. So one of the areas of one of the problems of concern in underwater sensor networks is the topology, basically. So underwater network topology, right? So what sort of network topology you are going to use, right? So we basically proposed this tic-tac-toe architectural topology, right? So tic-tac-toe game, right? So this topology basically looks like the tic-tac-toe game, and that is why so it was given this name of tic-tac-toe art. And so basically, using this topology, you can improve the overall lifetime of the network. So this is the advantage of this tic-tac-toe art, and this is what we have shown. So energy consumption basically reduces, and consequently the lifetime of the network, which is directly dependent on the energy consumption of the nodes, that basically the lifetime of the node network basically increases. Okay, so let me just check. Yeah, so we have a couple of more minutes. I'll just so what I will do is I will skip all of these, and I will take you through some of the different experimental works that we actually, all of these I had planned for you only, but we do not have sufficient time. So let me show you some technologies that we have developed in the Swan lab. So this is a very early work that we did about taken 7 to 8 years back, right? So which we named as the Swan sensor node. I hope that all of you are able to see how it looks. So basically, we built this sensor node. So the complete circuit diagram, etc., is everything we fabricated, the circuit, etc. So we did everything ourselves, and it has a rechargeable, source for charging this thing. So this thing we built as the one of the first works, and later on we used it for not only for sensor networks but also IoT networks. We continue to use it. As I was telling you that we started working on drones. We started getting our hands dirty with the assembling of the drones using commonly available components. Then we even got into the fabrication of the drones ourselves from scratch, completely like Make in India kind of thing. Completely developed ourselves. So this drone was made, and it was made to fly. But this one basically is not completely indigenous. But there are other drones that we had which was completely indigenous. Okay, we came up with our Ambusan system for ambulatory monitoring of patients. So this is basically typical of India, right? So like for example, like so let us say that from Aligarh, if you are going to Delhi, right? If you have to take a patient, right? So how do you monitor the condition of the patient from Aligarh to Delhi? Okay, so so the patient's condition may be different at different times, different places on the path, on the way. So how you are going to monitor the condition of the patient? So in our country, actually, nothing happens, right? So we do not monitor the condition of the patient. There is no, even in the ambulances also, there is no paramedic. So how you are going to monitor the condition of the patients continuously, remotely, how it can be done? So for this, actually, we came up with a system which is called the Ambusan system, meaning like ambulatory sensing system. In the ambulances, the patients, how they can be monitored continuously. This is the system. So wherein basically not only the onboard paramedic, but also the doctors, the nurses, and the near and dear ones of the patient, they can all continuously monitor the condition of the patient while the patient is in transit from the source hospital to the destination hospital. Okay, so this is basically this Ambusan system. It became very popular a couple of years back only. Whenever it came out, it became very popular. It was in the news, both in different newspapers as well as in the national television. Another thing, these are actually some real pictures of deployment of our agricultural sensor network on different fields. Some of the pictures are taken from IIT Kharagpur field, agricultural field, where these nodes, as you can see, these are some of these pictures of the nodes. Like this one, this is a sensor node, right? So one node, second node, like that. You have different nodes like this. So all of these different nodes, these have different sensors with them, like soil moisture, soil temperature, etc. So like that, water level sensor are also there. So all of these nodes, they continuously monitor the condition of the field, and you can you can get an idea about what is going on in the field. So remote monitoring of the fields is possible. So there is actually something called software-defined networking. I do not know how many of you have heard about it. Software-defined networking, SDN, right? So software-defined networking, basically, what it does is that certain aspects actually of the networks, these are software-defined. So you have the control plane, which is basically separated from the data plane, as it is called in SDN. So the control plane and the data plane, these are separated. So what happens is that you can improve the overall efficiency of the network in terms of programmability, in terms of configurability, and so you can do all of these things very efficiently. So we came up with a solution which was called the SoftWSN. Even we have the prototype of it also, which is software-defined sensor network management system. So you have a sensor network which is software-defined basically. So it's a SDN implementation on sensor networks. We have done that. We also built a couple of different simulation software for for underwater sensor networks and their simulation. So one is called the MacoSim, which is MATLAB based. The other one is called Jaltarang, which is NS3 based. So both of these underwater sensor network simulators, these are also very popular. These we have kept. These are actually open source, and we have kept them free for anybody to use. So whoever wants to use, they have to simply register themselves, and they will be able to get the password to get access to this software. Okay. These are actually publicly available for anyone to use. Another thing that we tried was underwater acoustic modem technology. So basically, so most of these underwater modems, these are extremely expensive in India. The cheapest ones per unit modem, the cheapest ones will cost you between 5 to 6 lakh rupees, 1 unit. We are talking about 1 unit. So I found that the way I got motivated is that when I began this project, it was an NRB project, Naval Research Board. I found that it is very expensive. So what I did is that I tried to build these underwater acoustic modems right from scratch in our lab, right? And we fortunately the way we have built, performance is not extremely good. It is not comparable to the performance that is obtained by most of these commercial underwater sensor nodes, but our performance that we are getting is reasonable enough in order to being used for some applications that are there for underwater, right? So underwater applications, so it can be used. Okay, so this is one part. So performance is not comparable. It is our system basically performs worse, but the good part is that it is completely built by ourselves, and it is very cheap. It is very cheap. Whereas the single units of these commercially available modems will cost you minimum 5 to 6 lakhs rupees per unit, ours is only couple of thousand rupees. So as you can understand that it is, in terms of cost comparison, so we have brought down the cost significantly, although we have to admit that our system doesn't perform as good as the commercially available systems, but definitely ours is usable. Okay, so with this, actually, I will stop over here. There are a lot of other things to be discussed as well, but in the interest of time, so I will stop over here. If there is any further question, then I would be happy to answer for next 1 or 2 minutes.
Thank you, sir, for your thank you, sir, for your lecture on IoT. Now, participants can have any question they would.
Participants may put their question in the chat box.
So, Dr. Abdul Samad, I think there is no question, then we can end the session. Time is almost over.
Please conclude the session, and because there is no question in the chat box. We have already taken more questions earlier.
For your participation in this FDP as a speaker, and we hope that
थोड़ा
we
सा
can always
अपना
have
mic
your
please, राशिद साहब please थोड़ा सा mic fix कर लीजिए.
So
Your voice.
So I wish that we can have you in future FDPs at our place, not virtual but in physical way, I hope. So thank you for your participation.
Yeah, thank
And
you.
with this, I think we can end the session. Thank you, sir.
Thank you very much, Professor Ali, once again, and also Professor Sama.
Okay.
The over here. Thank you very much for your participation, and
Thank you.
thanks for being patiently listening to me for the last 2 hours. Thank you. So
Thank you.
So kind of you,
Yes,
sir.
yes, sir. Thank you, sir.
We will be in touch.
thank you. Bye.
Okay. Thank you.
Sure.